My name is Soham Mandal.
Hi, my name is Grace Hercik.
Hi, my name is Audrey Transue.
Hi, my name is Jack Lorence.
Hi, my name is Fulton.
Hi, my name is Akshay, Balaji.
Patient caregivers that perform electrocardiograms or ECGs on their patients often struggle with keeping the 12-lead system organized and untangled, often exacerbated in urgent settings such as pre-hospital emergencies and transfers from EMS to a trauma team when time is crucial to care. Our proposed solution to this need is an ECG lead organization device that utilizes extension and retraction to waive the need to untangle leads every time they are being used and provide storage organization between uses.
Our ethnographic efforts spanned a wide variety of healthcare settings and providers. To name a few, we've been fortunate to meet with staff at a Level 1 trauma center, a local EMS agency, emergency medicine faculty here at the University of Pittsburgh, and a participatory activity on cardiac floors and ICUs at Canonsburg Hospital. With these efforts, we've been able to identify two key archetypes, nurses and EMS staff. Specifically, we've identified that these users fall in ages most commonly in the 30s and 40s with competency in 12-lead ECG placement and critical decision making.
Once we defined our unmet need, we began rapid concept prototyping to create as many design ideas as possible. This involved sketching, which included our various design ideas, and foam core prototypes with functionality. Using our prototypes, we then performed informal V&V testing, where we specifically talked to registered nurses and trained staff at Weiser. They interacted with and evaluated the prototypes, during which we conducted a series of questions to assess their design requirements.
The input that we gained from healthcare professionals guided our minimum viable feature set. The features we identified include the ability to have multiple retractable spools in one device, a portable and lightweight device along with a mechanism that allows attachment of it to ECG systems, and adaptability of our system to different lead lengths.
For hazard and risk analysis, we built a risk summary and an FMEA. We identified hazards like tangled or compressed leads delaying care, insulation breaches exposing conductors, and patient entanglement. For each hazard, we scored severity and probability, and then we flagged which risks were unacceptable and required specific design controls.
Given the risks we identified, we aimed to develop a design that minimized and controlled as many hazards as possible. For our design, our system uses individually coiled leads with each lead wound together through its own spool. These spools are linked by a connector piece. For convenience, V1 through V6 are housed together in a single casing, while each limb lead spool is placed on its own casing to preserve full range of motion during extension. To retract the leads, the enclosure is attached to the connectors, allowing all the spools to rewind simultaneously with manual rotation of a handle. Because cleaning difficulty was a key hazard determined, we designed a system so every lead can be easily removed and each component can be cleaned separately, improving overall safety and usability while mitigating risks.
For verification and validation of our ECG lead organizer, we will first perform verification testing using mannequins. Healthcare professionals will place ECG leads on a mannequin using the accessory while we assess whether the design reliably maintains lead organization, minimizes tangling, and actually reduces procedural time. Next, we will conduct validation testing using mannequins. Clinicians will use the accessory during real ECG acquisition to either confirm or deny that lead organization is improved and that parent ECG devices, signal quality, and clinical functionality are fully maintained.